Hi everyone, this is Bobby Harris, the Utility Broadband Alliance. As everybody is getting logged in here for our webinar, we'll hold just a second. I want to remind you all that you're all in listen only mode, so you're all muted, but you are able to use the Q&A, the questions tab, to type in your questions. If we have time at the end, we'll try to get to as many of those as possible. We always try to get a lot of those done. I know we might have a smaller group on today only because of some of the holidays, but that's okay. We will have this recorded and posted on the uvba.com website under the resources tab, of course. So it looks like everything is getting logged in. As I said, you're all on mute, and please use the questions tab to enter your questions for the panelists. And with that, I'm going to stop talking and turn it over to Mark Madden to do introductions and get our topic started for us. Mark, it's all yours, sir.
Thanks, Bobby. Thanks, appreciate it. Hi, folks. I'm Mark Madden. I'm I can't speak this morning. Senior Solutions Director for the utility sector at Ericsson. So I'm involved heavily in bringing new systems to market, as well as supporting customers. I'm joined today by Marcus Tornqvist, who is our Senior Portfolio Manager for our IoT platform services. And the reason we're here today is that as we've begun rolling out utility networks, and there's a number of them now, one of the things that I've noticed is that something that is potentially logistically challenging is often the last thing people think about. And if we can go to the next slide, as they are contemplating doing, let's go one more, contemplating doing their own private LTE network is SIM management. And it doesn't sound like a big problem. You know, after all, a SIM is just that little tiny card you try and put in your phone and then drop on the floor and kick under a table and then spend the next 20 minutes looking for. Not that I did that last weekend changing my phone. I deny everything. But it is actually a very critical thing to manage. And it also, when we start adding things like AMI to these networks, and the vast majority of them right now are going out with distribution automation in mind, which is, you know, a few thousand to a few tens of thousands of devices, can easily be managed in a spreadsheet. But if you add AMI, you've suddenly added a carrier-sized challenge to your network. So you have the potential for millions of SIMs to manage. Just 4 of our utility customers here in North America are going to be collectively adding over 12 million user equipment devices, which will all need subscriber identity modules over the next 10 years, some of them sooner than that. So the question becomes, how do you manage these millions of chips? And how do you provision and provide statistics for the UE? How can you track usage and location and monitor the performance of the end devices? We have E&M for the regular network equipment, but the utilities are deploying user equipment, which we don't tend to manage. So this, as I mentioned before, gives us quite the task. And generally speaking, we can't really do that with a spreadsheet. At some point in time, Excel will stop taking entries. So if we move on to the next slide, I want to talk a little bit first about what is a SIM. And I think that's useful information to have. We all know about chasing these things down underneath tables, but it's essentially just an integrated circuit, a memory card for storing information that specifies a specific piece of user equipment and its subscriber to an LTE network. It also holds some key data that's necessary for the network and the UE to operate on the network, which we'll see in a second. SIMs were first introduced with GSM. way back in 1991. That migrated when GSM evolved, which it fundamentally did, into UMTS. Again, mostly in the European market, for some American carriers as well, such as AT&T. It then migrated along with that side of the technology and then into LTE, and is now being used in 5G networks. It has had a number of different form factors since its introduction. It was originally a credit card sized device that went into this brick of a phone and has come down dramatically in size over the years. So now that the current batch is usually referred to as the nano SIM, which you can see here is about 12 millimeters by 9 millimeters. And that's the most common SIM in use today. There are some emerging form factors coming out. The eSIM is coming out. It's slowly gaining market acceptance. I don't know of any carriers yet that are using it, but it is gaining market acceptance in other markets. And it's essentially a smaller nano SIM soldered to the device, making it non-removable. So it's about half the size of the current nano SIM. Emerging onto the market now and just now starting to get some, I won't say traction yet. I think this is really more about getting discussion going and making it apparent that it's an available technology. Some manufacturers are looking to integrate the functions of the SIM into their system on chips on their devices, which takes that SIM function from a dedicated chip and embeds it into the device's hardware array. This has a couple of benefits because it saves cost. It's far less expensive to put the software on a non-dedicated piece of hardware. It reduces the power consumption of the device, which is important if we're talking about phones or even meters when we're looking at gas and water meters, which don't have a power source. So saving costs and power consumption. And then, of course, improving the device packaging because we're taking a fairly sizable IC out of the system. So physically, it's pretty simple. It doesn't take up a lot of space, but it takes up some. Doesn't take up a lot of power, but it takes up some. And we are looking towards taking it out of the equation completely, at least as a physical device. On the next slide, which we should move towards, I thought I'd give us a little primer on what's actually on a SIM. It does more than just identify your device. It supports things like advice of charge, which supports estimation of the cost of service. It also can support statistics of calls and things like that to give you an idea of the device usage. It keeps the 128-bit authentication key that is actually used to do the security handshake. It contains the mobile country code, so that's identifies the network what country the call is originating from. It contains the mobile subscriber identification number, which is another small number which identifies the subscriber to the network. And then something you'll probably have heard about before, which is the IMSI, or the International Mobile Subscriber Identity. This is basically the profile. So this is a unique number. It's actually made of 3 different other numbers, which are also stored on the SIM card. That's the 3-digit mobile country code, a 2 to 3-digit mobile network code, which identifies the network, and then the 10-digit mobile subscriber identification number. The MSIN is really, so we end up with 16-digit mobile subscriber ID. It contains the phone number of the device. That's the fancy word, Mobile Station Integration Services Digital Network. That's the device phone number. It contains the local area identity, which is a unique 3-digit number for identifying the device location in a network. So you could say a general area has a local area identity, and then the network operator tags that area with a specific ID. So you can capture the general area of where the device is operating or is supposed to be. It has a personal it has your personal identification number that you use to lock and unlock the device with on it as well. That's typically 4 to 6 digits. The service dialing numbers, which are the short form numbers that you can see on your phone for attaching to various services on the carrier's network, which are typically unique, somewhat unique to them. So things like voicemail or additional value-added services that you need to get to. It's the star whatever numbers. It contains the service provider name. It also has the short message service center. So this is where all your SMS messages are stored, along with up to 250 contacts in your contact list. So these can be moved if you need to move the SIM to another device. Now it doesn't store all, if you have 5,000 contacts, much of those are stored in your phone or on the cloud. The 250 of them can be stored on the SIM. It contains the unblocking code. Now the acronym POC isn't the sound I typically make when I've locked myself out of the phone, but rather it starts, it's the code for unlocking the device, and it's after you've forgotten your PIN and you have failed 3 times to restore or get access onto the device. You can get this unblocking code from your carrier or whoever the network operator is. They keep a record of that along with the other information on the SIM. And this unblocking code gives you 10 more attempts before it finally bricks the SIM and you have to replace it. It also has the ID number for the circuit card itself. And this is internationally unique. No SIM card, no 2 SIM cards carry the same UICC. And that, by the way, that's Universal Integrated Circuit Card. They use the U. And then it also stores some value-added services. So keys to value-added services or permissions for value-added services. It can also store small applets that might be on the phone for doing things like changing IMSI profiles on the SIM. So with the advent of eSIMs and iSIMs, it's become more, since those tend to be read-write as opposed to write once, read many. There's an opportunity to actually change the IMSI, which would allow you to attach to a different network, and that different network's going to know who you are. So customers are using that to perhaps start off with a carrier, and then as they've built out their private LTE network, they can merely switch the IMSI profile on the chip, switch to the primary IMSI profile on the chip, and now they're on their own network as opposed to the carrier network. So those are the kinds of things that are actually stored on the SIM. SIMs range in size from 8 kilobytes in the early days, and a typical nano SIM today has 256 kilobytes available on it to store this data. Next slide, Marcus. So with that, I just wanted to give a brief primer. Marcus is going to take us through how we actually manage this data, manage the SIMs, do the provisioning, store the data, keep track of statistical information that can be gleaned from that, and I will turn it over to Marcus now. Thank you.
Thanks, Mark, and thanks for the opportunity to speak here. Just a comment first, going further on the SIM card that we discussed. If you're having machine-to-machine applications or IoT, some of these are a little bit different, like the PIN code you don't need to enter typically if you're using a machine-to-machine code, machine-to-machine communication as an example. I will take a little bit step back and go into the evolution of the cellular technology. So I will first start with the 5G. We're talking a lot about 5G today. And what is the difference about 5G? It's not just more and faster than previous generation. It's the biggest challenge, I would say, is that first of all, it's not a big bang, so it's an evolution of change. So it's a step-by-step change in the technology. Most of the things, as in 4G, are software defined, so you can, let's say, do smooth upgrades and coming into the 5G domain. Another commercial thing is that we're supporting different type of connectivities. So it's not only for smartphones, but it's also for IoT and fixed mobile broadband, for instance. And to support the IoT use cases, we have a massive machine type kind of connectivity, which is the narrowband IoT or LTM, or low power wide area, that is also called. We have the evolved mobile broadband, of course, and also the ultra reliable low latency type of communication as well. Another aspect of the 5G technology stack is that we also can easier manage both private and public networks. I mean, we have started with private networks also in the LTE and 4G, but the toolbox, the capabilities increases with 5G. And this is some of the reasons why the cellular technology is becoming much more relevant to utilities in general. A trend that we see is, of course, that as utility companies, depending on which part of the value chain you're operating in, you have typically a number of different communication technologies in your portfolio that you're using. You have a lot of legacy communication technologies. Lifetime of many of these assets that you have in your distribution network or power generation plants stay there for a long time, and retrofit upgrades are often challenging. So you keep a lot of these technologies for many years and decades sometimes. What we're seeing now is that some utilities are taking measures to accelerate, let's say, their smart grid development by using cellular technologies and 5G to do that. And by that, they hope to be able to unify their communication technologies, which has impacts on cost, of course, efficiency, but also reduces security vulnerabilities, etc. To do this, you should know that it's a way of mixing different type of connectivities, cross different networks, cross spectrum, in order to do this. And you will then need to optimize different services that you have in your private or public network or hybrids, or if it's machine type or if it's whatever connectivity that you're having, and manage these connectivities in the optimal way depending on what use case that you're targeting. Mark mentioned also the volumes, and the connectivity in general. IoT connectivity is expected to grow significantly. It has already grown a lot, and the cellular part of that is significant to our own research, and we need to find ways to manage these connectivities, each individual subscription and SIM card in here. The largest areas or the largest use cases that we see is to the right. You can see that utilities are one of the largest that we have, and you also see that North America is one of the largest regions doing that. So this will absolutely happen in many parts of our society, but there are a lot of attraction today, both for utility and North America when it comes to investments and building offerings for these devices, products that are adopting these technologies to be relevant in this market. And I will come back to some of these use cases later on. The future, looking ahead and where we're heading against is, of course, the hyperscalers are moving into this space, obviously. They are adopting across the value chain. And from an IT platform point of view, it's about simplifying integration and consuming different types of IoT services in this space. We also see that the quest for automation and integrating different vertical applications on top of these technologies, meaning that it's API driven to enable automation end-to-end. Mark was mentioning eSIM. Today we see quite large adoption of this eSIMs at the physical circuit integrated on the circuit board. We see quite a lot of them, especially in IT devices. And you also want the flexibility to be able to read and write different attributes and characteristics of your SIM cards to make it more flexible and manage it, and that of course I will come back to. With 5G, new capabilities arrive also in the IT, meaning that it can be used for more purposes and use more flexibility of it. And also, as mentioned for utilities, the cellular technology itself becomes more relevant using that. Also, what we are looking at and doing stuff already is what we're calling edge. I mean, when you are adding artificial intelligence and machine learning into the mix, you typically need processing closer to the devices, where you're using the network and edge compute in order to serve the different use cases in the best possible way. We also see this emerging into the utility industry, where this is coming as well. Some of the typical SIM and connectivity management challenges is that, as Mark mentioned, when your spreadsheet doesn't really cope with all the devices that you have, that is one thing, but you also need to be able to monitor and manage these when they're operating in your network. Often you need to gather data from multiple systems, and you need to filter out the right type of data in this to make use of it. We see that they often have poor control and visibility into devices deployed with different partners into various networks. If you have devices in public and private networks, you may have from, again, different suppliers behaving a little bit different how you manage them. Also, the unification of APIs is often a challenge in order to understand what you can get from what supplier and device in that. And finally, the full device lifecycle management, from ordering, from configuration to deployment to operation, and finally disposal. What we see here is that the IoT SIM and connectivity management solutions in the market offers enterprises a unified way of handling device connectivity, making it possible to manage a single entity or large batches of SIMs. They can be done simultaneously. You can group them. You can put different characteristics on them. You can package them differently. You can set this different business rule. You can set priority different in order to manage that in the best way, and also utilizing your resources in the best possible way. The benefits that we can see is that you get real-time diagnostics, a view direct of your portfolio or fleet of IT devices. You are able to automate and integrate it to your own business applications and processes. And you also get a type of a one view or a single pane of glass to manage your fleet, and you can do it on a group level, or you can drill down to do it on single devices to understand how they are behaving. Some of the use cases that we have looked at specifically and where we see a great interest in right now in the market are related to the SIM management, as mentioned, and private networks. One of the key use cases that are often talked about is the single stock keeping unit, meaning that a device manufacturer that are shipping devices into your network, if you're a utility, it might be a smart meter, it might be something else. Especially when these devices are coming smaller and cheaper as a smart metering device, you can't afford having two modems or two SIM cards in that device. It doesn't make sense. And therefore you would like to have your SIM card being able to operate in both private and public networks, and you would like not to decide what network it should operate in when you're manufacturing the device in the factory somewhere in the world. So what this solution can do is that you're having a little applet on your SIM card that you have on your device. Again, this SIM card is typically an integrated device sitting directly on the circuit board. On that applet then you can store multiple IMSIs from the start. So when you're deploying the device, you can rotate between these IMSIs and understand what profile that you should use to connect to your network. It means that you can ensure that you can get a connection when you connect the device. When you have done that, you can use a bootstrap capability, meaning that you can download new SIM profiles or new rules to the device, how to behave in the future. So when the device is shipped from the factory, they may not know to what customer, to what country the device is heading. But when you're connecting it for the first time, you can identify it, and then you can provision it in the right way. You can add authentication keys, etc., that are relevant to the right customer of that device, as an example. You can then configure different rules to automate processes, and you can also use IMSIs for both public and private networks on the device. You can even, in this case, manage it in what we're saying foreign networks, and I will show that on the next slide as well. So the key use case that we see demand for today in the market is that, if I'm trying to explain the picture, you have an IoT device in the middle, which have then this SIM with a SIM applet. It has two SIM profiles, one public and one private IMSI. You could potentially add additional IMSIs from other public operators to have not only a second source but a third source, etc. So the first option here would be that it's connected to the private network of a utility company. But what if the private network for some reason doesn't have coverage, or it may be down for a period of time, so you would like to fail over to a public network? What happens is that when the device doesn't have connection, it will then scan for connection of the other IMSIs that it has on the SIM card, and as soon as it's find connection, it will connect. When it does that, the device will then be visible in the connectivity management system of the operator and not of the private network, so you will lose sight of it. You can still connect, you can get the collected data from it over internet or a channel that you have agreed with the public operator, but you will lose sight from a connectivity management point of view. With these SIM OTA management applications, you typically have an access directly to the SIM applet, so you can always see where the device resides, in what network it's connected, and you also have the capability of sending instructions to the SIM applet to, for instance, change network or restart or do something in order to, let's say, push it back to the network that you would like to have it in. So for these solutions, first you can get help with the, let's say, first connect to make sure that the device, when it's connected the first time, get the right configuration for automation to support the use case that is supposed to support. It can fail over to a public network and back. And when it is in a foreign network, you can still, let's say, reach the device to monitor it and manage it. Another use case that we have worked with for some years is smart metering. And smart metering is, of course, not something new. It happened a couple of years back. Maybe I didn't say it. You may hear it on my accent. I'm from Sweden, and a few years back, it was time for the second rollout of smart metering devices in Sweden. So we had the first generation already deployed, and it so happened that when the second wave of smart metering was planned in Sweden, the launch of narrowband IoT and LTM happened. The utility companies, as the meter vendors, were of course very proud of the existing solutions using RF mesh communication and power line communication, but we of course wanted to enable them using cellular IoT, meaning narrowband IoT and LTM. The journey started with this one, and just to understand in relation to other use cases, in IoT there is no single use case that have more potential devices out there than metering. There are 3 billion meters in the world, including electricity, water and gas, and that makes it the largest single IoT use case in terms of a number of devices. It also means that there's a lot of players investing in this area, and we can also see that the supply and in the market is quite good. The reason to go to cellular connectivity for smart metering, what we have seen is that first, as I mentioned initially, we see utilities today who want to unify their communication to reduce complexity of the different communication stacks. And they have seen the cellular communication technology and evolution to 5G as a possibility to unify different use cases on sharing the same communication infrastructure. And by that also then, when changing to smart metering, it has been a desire to also use cellular connectivity for that. Some of the utilities demanded that based on that reasons. Others saw it as one option out of many. One experience when you're having smart metering networks and operated them internally for power line communication or RF mesh is that you understand the complexity of running these networks. They have some different characteristics, of course. The later one is more resilient and easier to manage, of course, but there's still a complexity to it. You may have dependencies from the mesh networks that you cannot remove a certain device, etc. And when it comes to supply of maintenance equipment, etc., after a few years it can also be a challenge. So the cost and complexity of managing these private networks have been experienced. We also see from meter vendors first some resistance because they invested a lot in the technology that they are using, like their RF mesh stack or the power line communication stack. But we have also seen that many of the device manufacturers have seen the upside of using cellular IoT as well, even though we needed to showcase it and they needed to try and test, etc. The value proposition here is rather simple. I mean, you go from these what we call capillary networks where you're using a backhaul gateway that is typically connected with the cellular modem, and then you're having subset of meter devices connected to that using then power line communication or RF mesh. You also have a number of point-to-point meters typically that are using a cellular modem for, let's say, countryside deployments or where you can't justify an RF mesh type of network. When, as mentioned, deploying this, rolling out this, you have internal dependencies that you need to consider, and also when maintaining the network. What we did with the cellular network here is that these devices are kind of the same prices for the device using narrowband or LTM, but you can use the same device in every location. I mean, you can have single phase and polyphase and current meters, etc. But in general, you can use the same communication in all places. Of course, we were concerned when starting this journey that how good is the penetration capabilities? Are we able to reach devices in cellars where you have a lot of behind concrete and doors of steel? But it showed that it connects better, much better than we thought actually from the start. There are scenarios, of course, where you need to add external antennas in different variants, but in general, it connects very, very good, especially narrowband, I would say. What we did for these use cases was that we were looking at the different services, and the example of services here has then a European flavor since it's from Sweden. In US, it may be a little bit different since regulation is different. But when you're detailing the different services that you're using, you can also understand what is the payload that each device will generate, how does the traffic pattern look like in your network, etc. After that, we're looking to the right on the density of devices and can do network planning. What we experienced is that in urban areas, we can often have more than 1,000 devices per cell. In extremes, we have more than 5,000 devices per cell. That is very many devices in order to manage that. But the narrowband IT and LTM can cope with that. We also built business cases for different parties in order to understand the difference between the different communication technologies. To more justify and test it and try to change, let's say, a proven technology like mesh or PLC to a new technology like the cellular IT using narrowband or LTM. At the end, we did a number of rollouts in Sweden. We don't have the official numbers yet, but we are closing into having like 75 or 80% penetration of cellular IT when it comes to the second wave of smart metering rollout. So we were going from having between 10 and 20% cellular connectivity, a majority then power line communication, replacing them by narrowband and LTM. We often get questions on narrowband versus LTM. It depends on the use cases, of course, but my experience and what I recommend is that you're using modems that can do both narrowband and LTM, and that you can support both. They complement each other very well. To support battery-driven devices, narrowband is better for sure. And also when it comes to deep penetration, I mean, when the coverage is very poor, narrowband is having a very good capability to reach that device anyway. If you need more bandwidth, lower latencies, LTM is of course better. And again, experience is that combining this for your smart metering deployment is a very good choice. That is what we had on SIM management and looking at what we can support. Just to say that on the smart metering case here, having access to the connectivity management platforms in order to get accessibility to the underlying data, to troubleshoot, to optimize the processes, to integrate onboarding, rollout, etc., is of course very important. When you're connecting devices in the field, you would like to understand if they're working when leaving the site. You don't want to revisit sites. It costs you quite a lot of money. To get that, all of that type of support from your network and system is of course bringing a great value to that process. So with that said, thanks a lot.
Thank you, Marcus. Um, Mark, I'm going to have you come back on as well. And we do have a few questions from the audience. If you don't mind, if you've got a few minutes and we can take these together. I'll just read them out exactly the way they're asked. And I think you may have hit on this a little bit, Marcus, but the question says, can you talk a little bit or a little bit more about SIM updates? Some utilities may not be implementing SMS, and some user equipment may not support SMS. What is the approach you suggest to address these scenarios across a specific network?
Yeah, I mean, SMS is used for some traditional use cases in machine-to-machine and IoT, and there are many aspects to this question. One of them being that in many networks today you have support for SMS, but we're using only 2G and 3G to submit the text messages. And some devices then using massive IoT like narrowband and LTM, they can only speak LT, so they can't understand 2G and 3G. So it's important that you have support for 4G SMS in the network if you're going to reach your narrowband and LTM devices. Then I know that also many private networks are not using SMSs at all or not deploying and don't have support for it. For the SIM management applications that we have here, it's true that many of these are using SMS to reach the devices, to wake them. But you can also use other methods to push that. In this case, if you want a failover, so if you have a private network, for instance, that is out of reach, so the device connects to a public network instead, you often have a SMS capability in the public network, meaning that you can reach the device when it's in a public network to push it back to a private network. But in the private network, you don't need it to push it to a public network, etc. So if you're working and designing your use cases with the tools and equipments that you have, you can often design it in a way where you can, let's say, work around the lack of SMS in a private network.
Great. Thank you. Another question. Um, what core elements or functions outside of the SIM management tool are required to manage SIM on your own or foreign networks?
Yeah, these also have many different aspects of it. I mean, the SIM profile that you have, you have it in your home subscriber system or the HSS with UDM, where you can have so you know that you can attach and log into the system, of course. Then the SIM itself is managed by other system that is not in the core network, but centrally. So you can, with different type of authentication keys, access it and change and read and write to it via the applet in this case, and that you can do with the SIM management system. So there are many questions to that, of course, but you have some part of it for the IMSIs managed within the core network, and then in order to access the SIM itself, you can have other authentication keys to have the right to read and write via the applet to change some of these parameters.
Okay, great. Another important question here. What is the expected timing for iSIM wide availability for IoT and public carrier acceptance in North America?
Mark, is
That's
that for
good.
you?
Yeah, I'll try that one. So from what I've been seeing, there are companies out there now that are starting to make the modules. The widespread availability is going to be highly dependent on the industry demand, and for devices that that are extremely low power. We've got a couple more years before we start seeing a lot of them. Here in the United States, eSIM is just starting to get some traction, and it's been around for several years. So you can expect that's going to be another 2 or 3 years where we start seeing product come out. Now, of course, somebody like 4RF is going to make a liar out of me, but that's what I've been seeing so far.
Okay, great. Thank you. Here's the next question. If the SIM is connected to the public network, is the SIM applet capable of monitoring the private and public network, allowing the user equipment to return to the private network when available without intervention?
Yeah, this is a question down to the detail. So correct. It needs some. Yeah, the SIM, if I take it from that end, is not active at all the time. The SIM and the data on it is only needed when the modem asks the SIM to do something. So the modem of the device, if that is out of connection or it gets an instruction to read the SIM, it will do it. Otherwise, the SIM is not active all the time, so you can't reach it all the time. So it's only for certain operations that you can need it. So if you need an immediate actions from the SIM, you need to, let's say, wake it up or address it in one way or the other. Again, where an SMS is one natural way of doing it. But there are different ways to, let's say, do this. If, for instance, a device is losing its connection, it will then start rescanning and activate the SIM again. So if you're having it in a public network and you want to push it back, you can use different methods to make sure it doesn't have a connection, or you can send an SMS, or you can, yeah, there are different measures how you can do it back, but it needs some type of intervention typically, but that intervention can of course be automated.
Yeah, scripted.
Yeah,
So if it's on a public network, for example, and you want it to come back, you go out and touch it, make it read the SIM card. And then if you've set a priority for which IMSI is attempted first, then it's going to naturally go to that, right?
Okay, great. I'm going to read this one, this question. I think it's a two-parter, but
yeah.
um, we'll see if it makes sense the way I read it. So I apologize to the person who gave it if I slaughter it. Um, does the multi MSI service switch the profile, or if it switches, which IMSI that is used within the profile? And how long does the process take for failover? I'm not
Yeah.
sure I understand that, but I hope you do.
Yeah. So if you're using a UICC that we have today here, we are having one, let's say, the SIM that Mark explained earlier, the UICC is kind of containing a SIM profile in one way. Then you have the unique information that is needed to log into different networks that are, let's say, could be changeable via these multi-IMSI applets that was mentioned. And there are some data then on this SIM profile. So you can say that you have a virtual SIM profile on that the applet is managing. So in a way, you can say that the applet is exposing a certain set of keys and identifier to log into the right network it should, let's say, attach to. That is how it was. That more on the question there.
Okay.
I think there's some more to that. Maybe I can add. So if we're using NB-IoT or CAD-M, CAD-M1, NB-IoT doesn't roam. So that's a reset of the device. So going, kicking, and running the SIM applet to change the MC and then giving it a kick, you're not going to notice because it doesn't roam anyway. So it's going to come up and reset onto the new network. That's not the case with CAD-M1. It does allow for roaming, but you can still reach the card and still run the applet and force a reset on the device. And you know the device takes however long the device takes to boot back up. It's usually not very long.
Now, and as also said, when you're switching a SIM profile, you asked about the time. It's also to say that it can't carry, let's say, a voice call changing SIM profile in this case. So it will be a short break. It depends a little bit on the deployments that has been done on the modems. Some of them can change the IMSI profile without a restart. In some cases, a restart is needed on the modem. So it will take a little while to go over. Not a very long time, but you can't carry a voice call over as mentioned.
Excellent. Thank you. That is our last question.
Yeah.
So we are recording and we will publish this for those of you who ask about the recording of the session. But let me turn it back to you guys for any final comments that you'd like to leave us with today.
Well, if you are having a SIM management problem, give us a call because we think we can help. And a blatant plug there. We have our own SIM management application, as you might guess.
That's wonderful. Any final word, Marcus?
No, I think Mark concluded well here, so I stick to that. But thanks a lot for the possibility and opportunity to present this. So yeah, thanks a lot.
Well, I appreciate both of you. I appreciate you sharing your knowledge with us today, and always as members of UBBA, sharing on all of our working group calls and at the upcoming Summit and Plug Fest. For those of you who aren't aware, we will continue these deep discussions in Costa Mesa, California, in October. If you go to ubbaplugfest.org, you can see the full program. And these guys will probably be out there, or a group of folks from Ericsson, and you'll be able to ask more direct questions there live and in person. But in the meantime, thank you so much for joining the Utility Broadband Alliance for this important webinar. And I hope you all have a great rest of your day. Bye-bye.
Thank you.
Thank you.